A derecho is a widespread, long-lived, straight-line windstorm that is associated with a land-based, fast-moving group of severe thunderstorms. Derecho can cause hurricane-force winds, tornadoes, heavy rains, and flash floods. Convection-induced winds take on a bow-echo form of squall line, forming in an area of wind divergence in upper levels of the troposphere, within a region of low-level warm air advection and rich low-level moisture. They travel quickly in the direction of movement of their associated storms, similar to an outflow boundary, except that the wind is sustained and increases in strength behind the front, generally exceeding hurricane force. A warm weather phenomenon, derecho occur mostly in summer, especially during June, July, and August in the northern hemisphere, within areas of moderately strong instability and moderately strong vertical wind shear. They may occur at any time of the year and occur as frequently at night as during the daylight hours. Etymology: derecho comes from the Spanish word in adjective form for straight, in contrast with a tornado, which is a twisted wind. The word was first used in the American Meteorological Journal in 1888 by Gustavus Detlev Hinrichs in a paper describing the phenomenon and based on a significant derecho event that crossed Iowa on the 31st of July 1877. Development: organized areas of thunderstorm activity reinforce pre-existing frontal zones and can outrun cold fronts. The resultant mesoscale convective system forms at the point of the best upper-level divergence in the wind pattern in the area of best low-level inflow. The convection then moves eastern toward the equator into the warm sector, parallel to low-level thickness lines with the mean tropospheric flow. When the convection is strong linear, a curve, the MCS is called a squall line, with the feature placed at the leading edge of the significant wind shift and pressure rise. Derecho are squall lines that are bow spearhead shaped on weather radar and, thus, also are called bow echoes or spearhead radar echoes. Squall lines typically bow out due to the formation of a mesoscale high-pressure system which forms within the stratiform range area behind the initial line. This high-pressure area is formed due to strong descending motion behind the squall line, and could come in the form of a downburst. The size of the bow may vary, and the storms associated with the bow may die and redevelop. During the cold season within the northern hemisphere, derecho generally develop within a pattern of southwesterly winds at mid-levels of the troposphere in an environment of low to moderate atmospheric instability and high values of vertical wind shear within the lowest 5 kilometers of the atmosphere. Warm season derecho in the northern hemisphere form in west to northwesterly flow at mid-levels of the troposphere with moderate to high levels of instability. Derecho form within environments of low-level warm air advection and significant low-level moisture. Classification and criteria. Its common definition is a thunderstorm complex that produces a damaging wind swath of at least 250 miles, featuring a concentrated area of convectively induced wind gusts exceeding 50 knots. According to the National Weather Service criterion, a derecho is classified as a band of storms that have winds of at least 50 knots along the entire span of the storm front, maintained over a time span of at least 6 hours. Some studies add a requirement that no more than 2 or 3 hours separate any two successive wind reports. Derecho typically possess a high, rapidly increasing forward speed. They have a distinctive appearance on radar with several unique features, such as the rear inflow notch and bookend vortices, and usually they manifest 2 or more downbursts. There are 4 types of derecho. Serial derecho. This type of derecho is usually associated with a very deep low, single bow, a very large bow echo around or upwards of 250 miles long. This type of serial derecho is less common than the multi-bow kind. An example of a single-bow serial derecho is the derecho that occurred in association with the October 2010 North American storm complex. Multiple bow derecho are embedded in a large squall line typically around 250 miles long. One example of a multi-bow serial derecho is a derecho that occurred during the 1993 storm of the century in Florida. Because of embedded supercells, tornadoes can spin out of these types of derecho. This is a much more common type of serial derecho than the single-bow kind. Multi-bow serial derecho can be associated with line echo wave patterns on weather radar. Progressive derecho, a line of thunderstorms take the bow shape and may travel for hundreds of miles along stationary fronts. An example of this is the Boundary Waters Canadian derecho of 4 to 5 July 1999. Tornado formation is less common in a progressive than serial type. Hybrid derecho, a derecho with characteristics of both a serial and progressive derecho. Similar to serial derecho and progressive derecho, these types of derecho are associated with a deep low, but are relatively small in size. An example is the late May 1998 tornado outbreak and derecho that moved through the central northern plains and the southern Great Lakes on 30-31 May 1998. Low dew point derecho, a derecho that occurs in an environment of comparatively limited low-level moisture, with appreciable moisture confined to the mid-levels of the atmosphere. Such derecho most often occur between late fall and early spring in association with strong low-pressure systems. Low dew point derecho are essentially organized bands of successive dry downbursts. The Utah-Wyoming derecho of the 31st of May 1994 was an event of this type. It produced a 105 miles per hour wind gust at Provo, Utah, where 16 people were injured, and removed part of the roof of the Salt Air Pavilion on the Great Salt Lake. Surface dew points along the path of the derecho were in the mid-40s degree F. Characteristics. Winds in a derecho can be enhanced by downburst clusters embedded inside the storm. These straight-line winds may exceed 100 miles per hour, reaching 130 miles per hour in past events. Tornadoes sometimes form within derecho events, although such events are often difficult to confirm due to the additional damage caused by straight-line winds in the immediate area, with the average tornado in the United States and Canada rating in the low end of the FEF1 classification at 85 to 100 miles per hour peak winds, and most or all of the rest of the world even lower. Derecho tend to deliver the vast majority of extreme wind conditions over much of the territory in which they occur. Datasets compiled by the United States National Weather Service and other organizations show that a large swath of the north-central United States, and presumably at least the adjacent sections of Canada and much of the surface of the Great Lakes, can expect winds above 85 miles per hour to as high as 120 miles per hour over a significant area at least once in any 50-year period, including both convective events and extratropical cyclones and other events deriving power from baroclinic sources. Only in 40 to 65% or so of the United States resting on the coast of the Atlantic Basin, and a fraction of the Everglades, are derecho surpassed in this respect by landfalling hurricanes, which at the worst may have winds as severe as EF3 tornadoes. Certain derecho situations are the most common instances of severe weather outbreaks which may become less favorable to tornado production as they become more violent. The height of 30-31 May 1998 Upper Middle West Canada and New York State derecho and the latter stages of significant tornado and Severe weather outbreaks in 2003 and 2004 are only three examples of this. Some upper air measurements used for severe weather forecasting may reflect this point of diminishing return for tornado formation, and the mentioned three situations were instances during which the rare, particularly dangerous situation severe thunderstorm variety of severe weather watches were issued from the Storm Prediction Center of the U.S. National Oceanic and Atmospheric Administration. Some derecho develop a radar signature resembling that of a hurricane in the low levels. They may have a central eye free of precipitation, with a minimum central pressure and surrounding bands of strong convection, but are rarely associated with an MCS developing multiple squall lines, and are not tropical in nature. These storms have a warm core, like other mesoscale convective systems. One such derecho occurred across the Midwestern U.S. on the 21st of July 2003. An area of convection developed across eastern Iowa near a weak stationary, warm front and ultimately matured, taking on the shape of a wavy squall line across western Ohio and southern Indiana. The system re-intensified after leaving the Ohio Valley, starting to form a large hook, with occasional hook echoes appearing along its eastern side. A surfaced low-pressure center formed and became more impressive later in the day. Location: derecho in North America predominantly from April to August, peaking in frequency from May into July. During this time of year, derecho are mostly found in the Midwestern United States, most commonly from Oklahoma and across the Ohio Valley. During midsummer, when a hot and muggy air mass covers the north-central U.S., they will often develop farther north into Manitoba and northwestern Ontario, sometimes well north of the Canada-US border. North Dakota, Minnesota and Upper Michigan are also vulnerable to derecho storms when such conditions are in place. They often occur along stationary fronts on the northern periphery of where the most intense heat and humidity bubble exists. Late-year derecho are normally confined to Texas and the Deep South, although a late summer derecho struck upper parts of the New York State area after midnight on the 7th of September 1998. Warm season derecho have greater instability than their cold season counterpart, while cool season derecho have greater share than the warm season counterpart. Although these storms most commonly occur in North America, derecho can occur elsewhere in the world, although infrequently. Outside North America, they sometimes are called by different names. For example, in Bangladesh and adjacent portions of India, a type of storm known as a nor'wester may be a progressive derecho. One such event occurred on the 10th of July 2002 in Germany. A serial derecho killed 8 people and injured 39 near Berlin. They have occurred in Argentina and South Africa as well, and on rarer occasions, close to and north of the 60th parallel in northern Canada. Primarily a mid-latitudes phenomenon, derecho occur in the Amazon basin of Brazil. On the 8th of August 2010, a derecho struck Estonia and tore off the tower of Vikmaja Church. Damage risk: unlike other thunderstorms, which typically can be heard in the distance when approaching, a derecho seems to strike suddenly. Within minutes, extremely high winds can arise, strong enough to knock over highway signs and topple large trees. These winds are accompanied by spraying rain and frequent lightning from all directions. It is dangerous to drive under these conditions, especially at night, because of blowing debris and obstructed roadways, downed wires and widespread power outages are likely but not always a factor. A derecho moves through quickly but can do much damage in a short time. Since derecho occur during warm months and often in places with cold winter climates, people who are most at risk are those involved in outdoor activities. Campers, hikers, and motorists are most at risk because of falling trees toppled over by straight-line winds. Wide swaths of forest have been felled by such storms. People who live in mobile homes are also at risk. Mobile homes that are not anchored to the ground may be overturned from the high winds. Across the United States, Michigan and New York have incurred a significant portion of the fatalities from derecho. Prior to Hurricane Katrina, the death tolls from derecho and hurricanes were comparable for the United States. Derecho may also severely damage an urban area's electrical distribution system, especially if these services are routed above ground. The derecho that struck Chicago, Illinois on the 11th of July 2011 left more than 860,000 people without electricity. The June 2012 North American derecho took out electrical power to more than 3.7 million customers starting in the Midwestern United States, across the central Appalachians, into the mid-Atlantic states during a heatwave.